that everybody is on board. So we're officially starting at 3. I just want to make sure that we're all good to go. And sorry guys, I'm just trying to make sure that the stream is started and everything is okay. Okay, there we go. So I will check back in with you guys in a little bit. You are welcome so long to pop a message in the chat if you are not a PHA learner, just so that we can kind of get an idea of where you're coming from. This stream is very specifically made for the PHA learners, but everybody is absolutely welcome. And like I say, I'll check in with you guys in about 5 minutes so that we just know who's good to go and. Alright guys, so I am going to mute myself, so don't freak out. I haven't completely disappeared on you. Alright guys, it is just past 3 o'clock. The stream was supposed to start at 3. For all the PHA learners, there is a Google form link in the chat that you can complete to do your attendance. Ladies and gentlemen, if you are joining from somewhere else, I just want to make the kind of situation completely clear to you. We are both live streaming and doing in person at school. So there might be some audio. If a learner in class asks a question, I will repeat that question so that everybody can hear the question. If you are on the live stream watching from home, then you can put your questions in the chat. There is a delay between the chat and when I see it on my side. I am going to do my best to pause after each topic and then deal with any questions that I see coming up if I miss them as we go. Alright, so I just want to make it very clear, if it is a bit noisy, it is because we have actual human beings also in front of me, all coming and going. We are at school, so you might hear some other noises as well. And then if you are in the chat, you use the chat in order for you to ask questions. And then if you are a learner from PHA, Protea Heights Academy, you need to please complete the Google forms that I posted in the chat. That will be the attendance register. Any learner who is physically here, I will add to that attendance. Alright guys, I'm just going to give it 5 more minutes and then we're going to start. And as soon as we start, I'll give you guys a quick rundown. I'll give you guys a quick rundown of the order of which we're doing in questions, because all of you are saying you're tired. I know math apparently was terrifying. I know the kids that wrote EGD on Thursday were equally unhappy. And so I get that right now you guys are tired. I get right now you might feel despondent, I think would be a good word to use. But I really do hope that we can get through this question paper pretty quickly. In the description, there is a Google Drive where you can access the question papers as well as the memos. I've broken them down just a little bit, but I'll see you guys in about 3 minutes and then we're going to do this. Alright, so I've caught up on the chat a little bit. Sure, guys, I'm sorry. I had a look at the math paper. I saw it was very comprehension based, which I suppose, you know, they went all math on the physics paper last year. So maybe they were just trying to get you guys back for that problem. I don't know. Anyway, right, so you don't have to have a physical copy. You can work electronically. I am also working electronically. Hey, see, look, there, fingers. Obviously because this is YouTube Live, it is going to be recorded and you guys can go at any point to the video. I still don't, well no, I probably do know how to timestamp things, but that might just be a problem. Okay, so PHA kiddos, I also need you to just remember that this is on the big wide world out there. So even though I understand completely that you do need to have a bit of a talk, okay, I really do get it. Please also just be respectful that we might have guests. You know, anyone is able to find this YouTube stream. Okay, now, because life has been a little bit tough in your life, I thought we'd ask and start with nice questions, okay? So I'm not going to follow the normal order, all right? I am going to start with Doppler, and then I'm going to do the photoelectric effect. Then we're going to go to mechanics, and then we'll do the electricity later. I'm going to try and get you in and out of here in 2 hours. I cannot promise, but I really will try. I've got a bottle of water ready, I've got a cool drink ready, I'm good to go. Alright, and I've prepped the paper quite seriously, so you're going to see quite a few things going. Okay, so here we go. We're going to start with Doppler. Doppler. Okay? Doppler. Right, there we go. So, for those of you who aren't aware, I'm working through the Free State September 2025 paper. Why? Because they tend to ask interesting questions. Okay, so here we go. Question 6, Doppler normal. Okay, two identical aircrafts, A and B, each produce a sound wave with a frequency of 600 hertz. And instantly I'm taking a highlighter and I'm going, ooh, 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 that is the frequency that the source is sending. They start moving at the same time, but they move in opposite directions. I hope so, otherwise we're having a crash and burn. Okay, they move away from the airport tower. There's a little diagram. They say a listener in the airport tower measures a 30 hertz decrease from the actual frequency of A, while B experiences a frequency, or they hear a frequency of 450 hertz. Now I did at least write down the variables in a moment, but we'll get there. And then they give us V, the speed of sound in air, as 340. Alright, they're quite nice here. They say name the phenomenon that describes the apparent change in frequency observed. Alright, so we know that that is the Doppler effect. Ladies and gentlemen, you cannot just write Doppler. Okay, if you just write Doppler, you're not going to get the mark. They're being quite kind here. It's 1 mark, you just have to state the thing. If you had to write the definition, this is one you guys struggle with, but there's only one definition here. Okay, so get it. Alright. Then 6.2, how does the frequency heard by the pilot in aircraft A compare to the actual frequency of the sound waves produced by aircraft A? Right? Higher than, lower than, remains the same, and give a reason. So, ladies and gentlemen, the pilot sitting in aircraft A is moving with aircraft A. They do not have velocities relative to the sound propagation. Their velocities relative to the medium of sound propagation is the same. No Doppler effect is happening there. Alright, so the pilot in aircraft A hears the same frequency that is sent out by aircraft A, so it remains the same. And the reason for that is because the sound source and the observer are not moving relative to each other. That 2 marks there is very deceptive. I double checked the memo. It is 2 marks for just that statement. I do think it's unfair, but hey, what do I know? Alright, so just that one statement, they are not moving relative to each other. I actually quite like this question, I'm going to be honest. I wish I would have thought of this question. Okay, now we're going to go to the calculation part of Doppler. Okay, So they are asking us to calculate the distance between the two aircrafts after they have moved in opposite direction at constant velocity for 60 seconds. And now all your wheels come off, right? And I'm going to remind you that we are busy with question 6. Not question 2, not question 3, not any mechanics. We are busy with question 6. And so I want you guys always to go, could I use Doppler effect in this situation? All right. So it's quite a heavy mark. It's fine. We'll get there. All right. So I wrote down all the variables. I said the frequency of the source, 600 hertz for both A and B. The velocity, speed of sound in air is given as 340 meters per second. The frequency that the listener hears for A, they state in the question there is a 30 hertz decrease in the actual frequency. So I went 600 minus 30. That means that the frequency the listener hears for aircraft A is 570 hertz. Then they tell me the frequency that the listener hears for B is 450 hertz. And I just want to remind you that the object that is observing the tower is stationary. Okay, so from that, you can at least calculate the speed of the sources. All right? Now, I have picked up and I have warned you guys about this before. If you only write a part of this equation, and a part of this equation includes only writing a plus and a minus at the top, or a minus and a plus at the top, they do not give you the formula mark. Okay? You have to write the complete, the entire, as given formula for Doppler effect. Please do not throw away those marks. Alright, so I am going to start with aircraft A. For aircraft A, the listener observes a frequency of 570 hertz. We are given the speed of sound in air. Aircraft A is moving away from the tower. So minus at the top and plus at the bottom. The observer is stationary, and we are going to calculate Vs, the velocity of the source, and we have that the frequency of both aircraft A and B is 600. Alright, you guys get a little bit difficult here in terms of manipulating, and each of you guys will have different manipulation tactics here. Alright, so I need you guys, when you are working through this question on your own, to, let me write it in blue, you need to go and figure out how you are going to calculate Vs. I got the source as having a velocity of 17,88888. So let's go 89 meters per second. I am going to do the same for B. They cannot give me another formula mark, so I'm simply going to say for B, the observer heard a frequency of 450. Speed of sound is still 340. The observer is still standing still. And I want to know at what speed B is moving. And again here, you need to go and check whether or not you are able to calculate that. Now remember, if math is really hard for you, that substitution is going to carry marks and that substitution is going to carry marks. You are going to lose marks down, right? You are, but at least you can get formula subs and subs marks. Right, so when I manipulated that guy I ended up that B had a speed of 113,33333 meters. Okay, so now at least I have the velocity of the two. And now I want you guys to remember, right, that with velocity, average speed, we can work out average distance. So for A, I'm going to say 17,89 is equal to however far I drove in 60 seconds. Why? Because the question says so. Okay? And that's not the hardest problem in the whole wide world. Obviously, there are some spots here where you could just do it all in one go. That's never been my preference. You guys should know that. I get 1,073,4 meters, because remember that's in meters per second, and that's in seconds. And for B, I go 113,33 is equal to the distance in 60 seconds. And I got a lot. 6,799,8 meters. Alright, now if you look at the picture, which I need to find in this mess that is my life, there we go. They want to know what is D, the distance between aircraft A and aircraft B after 60 seconds. Right, so all I have to do here is I have to say 1,073,4 plus 7,699,8, and if my math is correct, which it often isn't, but we'll go with it, 7,873,4 meters. Alright, so that was the big calculation question here for Doppler. A little bit harder, I think, but as long as you keep in mind that with Doppler, you are going to use Doppler effect. Alright, so the one question I got here, if we could use equations of motion here. So I suppose you could use some form of equations of motion, but you would still have to get the velocities. And very, very clearly, they do say that both planes move at a constant velocity, which is a bit dumb, because I don't think they actually do move at a constant velocity, because, well, they start from stationary. But I suppose I understand where the question is coming from, but you're not going to have enough information. The only thing you have is time, and you want delta x, and you don't have acceleration. So that it would be very, very hard in this case to use equations of motion successfully. I'm not saying you can't. I'm just saying that it might not benefit you. All right. So what I did, those of you who I teach will know, whenever I do a longer form question of a topic, I also like to look at the multiple choice for that topic. So here's the Doppler multiple choice question. It says, an astronomer on Earth observes light with a wavelength of lambda, and it is moving away from the Earth. Keep in mind that when things move away from things, the frequency observed is smaller, less than the frequency that is sent out. And if you remember, the speed of light is equal to the frequency times its wavelength. So if the frequency increases, the wavelength must decrease, because the speed of light, she does not change. So the wavelength observed will be bigger than the wavelength sent out. So you are looking at A for this question. Just here, they didn't use this idea of stating the applications of the Doppler effect. Please go make sure that you go over that. It's easy marks. And then the whole idea of redshifts, I also didn't see in this question paper. Don't forget that blue shift is an application, sort of-ish, of redshifts. So don't miss out on that. Okay, red shifts moving away, so blue shifts moving towards. And then make very sure that you can do this explanation. I had a conversation with a couple of grade 12s earlier today. Don't forget that ChatGPT can help you if you have these little weird statements in the exam guidelines that isn't explicitly stated. I've used ChatGPT quite extensively in this regard, so don't be too scared if you run into these to ask ChatGPT to give you a quick, easy statement that you can write down. Just maybe verify it, but ChatGPT in this situation is relatively correct and relatively accurate because the work that we are doing for grade 12 is on the lower end of the entire physics spectrum. That's not supposed to say that the work you are doing is not hard for you. That's not what I'm saying. I am saying that if there are statements that you cannot find in your textbook or in your PDF or anything like that, that AI is not the worst place to go and find those. Alright, so we did Doppler, and now we're going to go to the other foster child in the paper, question 10. For those of you hearing the clanking, I just got 3 guests in the classroom. Fantastic, I'm not all by myself. Alright, so I'm going to work through the photoelectric effect, and then we will go and deal with mechanics. Alright, so photoelectric effect. This is a very strange question. We'll deal with it. Okay, so they tell you you've got incident light. It's shone onto a metal surface. I didn't call you stupid. I just said that the work is on the lower end of the totality of physics and physical sciences. Okay, guys? Some of the actual chemistry in real life and the actual physics in real life is so in-depth that it goes over my head. Okay, so please don't for a second think that I think you guys are unintelligent. What I'm saying is, in the vast scheme of things, with all the information out there that AI has access to, the work that we are doing is completely within its abilities. Okay. Alright, metal surface photocell. Learner uses a photocell to determine the photoelectrons emitted, right? Incident light DC source. Then we are kind of like work function type of metal. That was me going and Anyway, then they go, the total output power of the electromagnetic radiation waves from the surface is 3,2 times 10 to the power 27 joules per second. Okay, it's fine. It's going to be okay. I know that's a new concept, but it's going to be okay. They say the wavelength of the incident light is 5,2 times 10 to the power minus 7 meters. Okay, so here I want you guys to remember that incident light, we are going to work out energy of the incoming light. Okay. Define the term photoelectric effect. I did a bit of cut and paste from your exam guidelines. So there's only 3 definitions in this topic. The photoelectric effect, threshold frequency, work function. No? And then, weirdly here, the second bullet, they say, state the significance of the photoelectric effect. And then, right at the end of this entire bit in your exam guidelines, they say, state that the photoelectric effect demonstrates the particle nature of light. Those 2 bullets are the same bullet, okay? So don't go and find extra information. Right. So, state the term photoelectric effect. It's the process whereby electrons are ejected from a metal surface when light of a suitable frequency is incident on that surface. Guys, I need you to memorize your definitions as if all of them are going to be marked 2 or 0. Okay? Because you don't know. Okay. Right. Huh. Calculate the number of photoelectrons emitted per second from the metal surface. So, per second from the metal surface, I kind of knew I had to use that weird output power thing, but we will get there. Alright. So, when I started this question, when I was prepping it, I realized that the one thing I can use, the one thing I know for sure I can use is this, the wavelength of the incident light. Okay? So I went, you know what? Nothing to lose. Let me go and calculate the energy of that incident light. I've got nothing to lose. Okay? So the wavelength energy calculation is E is equal to H times C divided by lambda. Alright, so H is on the information page. Plancker's constant. 3,36 times 10 to the power minus 34. C is on the information page. 3 times 10 to the power 8. Can you all see that I'm drawing the fraction lines? More and more I start seeing people leaving out that fraction line. You leave it out, they won't give you the substitution mark. Yes.
And what is E?
E is the energy of the incoming light. So that is what I'm busy calculating. So I am busy calculating the energy of the incoming light, and I am doing that by using the wavelength of the incoming light. It's in the question. Yes.
Why are we calculating the energy?
Because,
the number of protons?
okay, so the question here is, why are we calculating energy when they're asking me for the number of photons? Because I know how to calculate energy. Okay? I had no clue when I started this question how to get to photons. But I knew I could calculate the energy. And I saw that that was 6 marks.
So it's more than one.
Exactly. So I knew there was more than one calculation going on. So I thought, you know what, let me do what I know how to do. Okay, alright. So you plug all of that into your calculator. Please be careful with all the brackets and the functions and the exponents and the things. And I got 3,82 times 10 to the power minus 19 joule. Okay. So then I kind of went and thought about the word power. Yes.
And isn't it 3,225?
Yes, you could use 325, yeah. Hang on. Double check my calculation. No, I really don't mind you guys double checking me, because my ability to use a calculator is suspect on a good day. Minus 7, 3,825, very good point. Okay, it would round to 83, good job. Perfect, well done, good catch. Alright, so, now I went and I thought, okay, what is power? Okay, and I know everybody's snickering, that's my normal joke, what is power, because the unit of power is what. But anyway, so, power is energy per unit time. Remember that, rate of change of energy. And so, if we're dealing with this idea of, where's that word? The total power output of the electromagnetic radiation. Okay? Then it's the energy per photon. You see there, energy. Number of photons. Can you see per photon and number of photons would cancel each other out? So this would be per photon times the number of photons. They would cancel each other out per unit time. Okay. And so ultimately, what we are going to do is you're going to take that given output energy, the 3,2 times 10 to the power 27, is equal to the energy we just worked out. That energy, that is the energy per photon. Every single light that comes in has that amount of energy. So that is equal to that 3,825 times 10 to the power 19 that we just calculated, times the number of photons per second. And ultimately, what did they ask us to calculate? The number of photons per second. Okay.
And this formula, what power is equal to energy times number of
Not. This is a very high level 3 calculation. I personally think it borderlines on a level 4. The reason why I included this in our paper today is because I've seen these weird ideas popping up more and more and more. These little weird, but how am I supposed to do that questions. Now, if you look at the marking scheme, this part here is 3 out of the 6 marks. So if you can just calculate the energy, that's 3 out of 6 marks. And 3 out of 6 is better than nothing out of 6. And I say this to you guys regularly, okay? Regularly I say, even if you're not quite sure how to end, take what is given and start. Okay, so I get 8,366, which of course you can round to 37, times 10 to the power 45 photons. A lot. A many lot. Yes.
Now we find out, how do I put that my calculator in scientific, in the scientific
That.
notation? I don't put, because I got a large number of it.
Okay.
I don't put it in scientific.
Right, so what I did is I went 3,2 exponent 27 divide by 3,825 exponent minus 19. Okay, now my calculator gives it to me already in scientific notation. And you see that side, you see that. So you literally write down the first 3 decimals, 8,366. You ignore all of it, and then you go find the times 10 to the power. Really? Mine doesn't even have that ability. Okay, so from the floor here says, if you get really big numbers and you want to turn it into the scientific notation, you press ENG. Just don't press recall, because that's not going to help you. I also know that you can go to the setup and norm 1 gives it to you in scientific, and norm 2 gives it to you more in numbers. Alright, from the chat side, I don't see any questions. Okay. Right, not a nice photoelectric, but that's okay. Alright, so let's go look at the last part of the photoelectric questions, where they ask, how does this affect this? Okay, so they say we need to focus on the maximum kinetic energy, okay, EK max. Right, so when the incident light of a shorter wavelength is used. Now remember, our formula for energy, when we're talking wavelength, is hc divided by lambda. So if I'm dividing by a smaller number, then the energy of that wavelength is bigger. Good job. And keep in mind that E is equal to work function plus EK max. They didn't say anything about a different metal here. So if the energy increases and the work function of whatever we are dealing with stays the same, then the EK max will also increase. Okay. Shane asked if there's a unit for N. No, it's just number of photons. Okay. Right. 10.3.2, a metal with a higher work function. Keep this in mind. Keep this in mind. They didn't say that the energy of the incoming light is changing. See that? They just say there's a different work function. And not only that, they say higher work function, bigger work function. So more of the energy is used to release the photoelectrons, which means there's less energy left over for the kinetic energy. Okay. Now, the incident light is greater intensity. I'm going to say this probably 1,000,000 times still this year, and probably 1,000,000 times still in my lifetime. Okay? Intensity tells me how many light incident per second. Okay? So even though a bigger intensity releases more electrons per second, if the frequency does not change, the energy does not change. And if the energy does not change, the kinetic energy does not change. So intensity has no effect on kinetic energy. Okay? You got that? Intensity does not change the kinetic energy. Kinetic energy is changed when the energy of the light source is different, or if the work function changes. One of these two have to change for kinetic energy to change. Intensity changes the current, I, because there's more charges. Okay, right. Okay, so that was the longer question. And then the multiple choice question, yeah, I thought was quite fun. Same as this, as the weird calculation. So, the number of photoelectrons emitted by an incident light of frequency f. For some other reason, they felt it's important to say that the frequency is bigger than the threshold frequency, but anyway. And they want to know the number of photoelectrons emitted is proportional to what? And then they give you threshold frequency, frequency of light, intensity of light, and they do this minus sign. Okay, so the threshold frequency is of the metal. The threshold frequency has got nothing to do with the incident light. Okay? Nothing to do with the incident light. Got it? And the threshold frequency does not affect the number of photoelectrons. It affects their kinetic energy. Same, the frequency of the light influences the energy of the incoming light, not the number of. There we go. I looked at this F minus F, the threshold frequency thing now, and I realized that basically what they try to get you to brain out is E minus work function is EK max. So can you see it also can't be D? Again, intensity, number of. Now this is not the answer that the memo gives, but I double checked it. That is the correct answer. Okay. The memo says the answer is B, but it's not. The number of photoelectrons emitted has got nothing to do with the frequency. Number of photoelectrons emitted has got to do with how many photons reach the metal surface. Indy, you must just, which question are you asking for? Okay. Right, so there was a request for electric circuits. Now my plan was to do mechanics and then do electricity, but I have absolutely no issue in doing the electric part of it, the electrostatic, electric circuits, those as a combined thing. Okay. What I do want to point out to you is that this question paper had nothing in about emission and absorption spectrums. Okay. So it's not that I'm not dealing with it because it's irrelevant. This question paper had nothing about emission. Oh, okay, I see which one Andy wants. Right, give me a sec. Okay. So, the question from the chat here, guys, I know you can't see the chat, is to just deal with that idea of intensity again. Okay, so, intensity is how many photons land on the metal per unit time. Okay? Which means that you have an increase in number of photoelectrons emitted per unit time. And if you think about it, charge per unit time is the current. Okay. So, if they ask you about intensity, the only thing intensity changes is number of photoelectrons per unit time, which then affects the current. Okay, I'm quite happy to do electric circuits. It's the one I always mark, so it's the one I'm more comfortable with. Makes me happy. Love electric circuits. Okay, so let's do that then. Go. I don't. I never have hand sanitizer. A sharpener. Ooh, no fire start with. Liam's got one. Okay. Alright, guys, you wanted electric circuits? Let's go electric circuits. So what we're going to do is we're going to skip the mechanics for just a moment. There we go. And we're going to do Coulomb's law, electric circuits, electrodynamics. So Coulomb's law, electric circuits, electrodynamics. And then we'll go back to actual mechanics. Okay, so the Coulomb's law question here, the electrostatics question, is question 7. That's pretty typical where electrostatics falls within that question paper. And then electric circuits, question 8, and electrodynamics, question 9. Alright, so they say that you've got a metal sphere on an insulated stand in a vacuum. Oh my goodness, that is so isolated, it's not funny. Then we've got point P here, and they have a 90 centimeter gap here. Ladies and gentlemen, you have to convert to meters. So you divide by 100. 90 centimeters is equal to 0.9 meters. Okay. Then 4,625 times 10 to the power 10 electrons are removed from sphere A. Removed. Meaning sphere A is does say electrons are negative. If I take negative stuff away, people become positive. Okay. Point P is 90 centimeters away from sphere A. Right. Firstly, they say state Coulomb's law. There are 3 definitions in electrostatics. Coulomb's law, describe an electric field and define an electric field at a point. Okay? So, those are the 3. Right. So, Coulomb's law, the magnitude, they don't worry too much about the word magnitude, but they want the electrostatic force exerted by one point charge on another is directly proportional to the product of the magnitudes, also magnitudes not the most important word, of the charges and inversely proportional to the square of the distance between them. Why can you get away with saying between them? Because you've said one point charge on another. Point charge, literally a little speck dot in the middle of nowhere. Okay. Then, quite a typical question for 7.2. Why did I put A on an insulated stand? What is important when we're doing calculations? We need isolated environments. Okay. If you do not put charged objects on insulated stands, the charge can go everywhere. So the reason you put a charged object on an insulated stand is to ensure that charge is conserved or to create an isolated system. Any of those arguments. Okay. Quite typical, I've seen it before. Yeah, not a weird question to ask. Like I said, I've seen it quite a few times before. Alright, now 7.3 is a grade 10 question. Whoop whoop. Of course you can. Right. Question 7.3 is a grade 10 question. Calculate the charge on sphere A. Right? Again, I just want to remind you. So the question is, can you say it's isolated so nothing neutralizes it? I would be careful of the word neutralize, but the word so that it is isolated is perfect. The word isolated will get you 2 marks. Okay, so grade 10 question. No one believes me in grade 10 when I say that content from grade 10 will come back in your grade 12 paper, but yet here it is. Alright, so N, the number of electrons, is equal to the charge divided by the charge on an electron. This formula is given. In the question, they say that 4,625 times 10 to the power 10 electrons were removed. They want to know what is the charge. And now you've got options with this 1,6. You can use minus 1,6. But ultimately you need to have a positive final answer. James, sorry, your question just popped through for 7.2. Absolutely, to ensure the charge is conserved for 2 marks. I know there's a couple of places in this question paper where they give 2 marks for what I consider to be a 1 mark answer, but I suppose they do have the right to do that. Unfortunately, there's not much you can do about it. If you are ever concerned, then rather write more than less. Tunnel where to? Yes, momentum is coming, don't worry. Momentum, Newton's laws, all of those are coming. Yes, of course, you don't have to ask. Okay. So again, grade 10 question 7.3. Alright. 7.4. Calculate the magnitude of the electric field due to A. Now, you've got 2 equations for electric field. Okay? The one is E is equal to K times capital Q divided by R squared. And the other calculation or other formula you could use is E is equal to F divided by little q. Now, I heard, I think it was last year, a very, 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 very good statement. If they are asking you to calculate an electric field because of a sphere, you use the capital Q. Capital Q is causing. Little q is the charge that experiences the electric field. Okay. So So if they ever ask you this question, magnitude of the electric field at a point due to A, it's due to, so I'm using capital Q. I absolutely love what you guys are doing in the chat. For that charge, yes, you could say positive, but I cannot imagine that they would penalize you if it's not a positive there, as long as it's not a negative answer. Okay, so this is a situation in which positive marking is going to be applied. So whichever answer you got at 7.3, you would then use in 7.4. K, Coulomb's constant, 9 times 10 to the power 9. When we plug into Coulomb's law and or electric fields, we never indicate the sign. So whenever you're plugging into electric field or into Coulomb's law, you just plug in the value, not the sign. The sign tells you in which direction. Okay, so divide by 0.9 for that 90 centimeters squared. Okay, I made a note for myself here at the bottom. 7.4, the question is calculate the magnitude of. So you don't have to include a direction. I also just want to make it clear that if you do include a direction and you are not asked for a direction, they will not penalize you. Alright, so I get in electric field as 82,22, more twos, and more twos. Right, electric field is Newton per Coulomb. Newton per Coulomb. Alright, the unit must be there. And again, they said magnitude, no direction. Okay. Now, before I looked at question 7.5, because I thought it was an explain question, I was like, okay, let's just make sure, because, you know, solve problems using F for 2 charges or 3 charges in a straight line. Yes, of course. Straight line or 90-degree angle, and then there's the 2 equations. And then I saw question 7.5 and I was like, oh, okay. Alright, so let's quickly catch up on this chat. The question is little q or big Q more or less the same thing? So both little q and big Q stand for charge. In the electric field calculations, if the formula has a little q in it, it's because the charge experiences the electric field. If it is a big Q, like we used in this example, it's because the charge causes the electric field. But yes, little q, big Q, both stand for charge. Okay, I hope you guys are ready for 7.5. I thought it was horrible and then it wasn't. Okay, here we go. So, the reason why there's no calculation of Coulomb's law in earlier is because here it is. They say another sphere B carrying a charge of -5 nano, -9 coulombs is placed at point B. And then I got confused because then they said calculate how far from point P sphere B should be to decrease the net electrostatic force between the 2 spheres. And of course my brain went, So I thought, hang on a second. We are talking about A, B, and point P, and they're talking about electrostatic force, right? So again, I kind of thought, hang on a second, why don't we just use A, use B, and the distance, if I placed B exactly at point P, and let's calculate the electrostatic force that the 2 spheres will exert on each other. Okay? And again, this is one of those situations where I went, I'm not quite sure exactly what to do, but I'm pulling words from the question and I'm just starting with what I have. So, Coulomb's law, F is equal to K, QA, QB, you could write Q1, Q2, divide by R squared. Okay? So, we had A, and then here we had point P. Now we are placing B with a charge of minus 5 nanocoulomb at point P. So they are still 0.9 meters apart. Okay, so I plugged in to Coulomb's law, and again, when I plug into Coulomb's law, when I plug into electric fields, I don't plug in the sign of the charges. The sign of the charges is just going to determine in which direction the forces are acting, or in the case of these two, whether the forces between them is a force of attraction or a force of repulsion. Right, 7,4 exponent minus 9. 5 exponent minus 9. Those of you who are panicking, don't forget that that 7,4 there, positive marking. Now, they have to mark with a mistake. They have no choice. Whoever set the paper, well, tough. Okay. I get 4,111111111 times 10 to the power minus 7 Newton. Okay. And then when I read the question again, I realized that this 4,11 times 10 to the power minus 7 is what I could consider 100% of the force. If you read the question, I now want to decrease that force by 15%. Okay? And if I decrease the force by 15%, that means I need to know what is 85% of that. F is for the electrostatic force. Right, so I'm going to take that value, 4,11111. You can write as many decimals as you want, as long as there is at least 2 of them. And then I get 3,49, and then the 4's repeat themselves. Minus 7 Newton. Okay? Yes. I'll give you my page so you can double check it with me. Okay, so they want to know if I keep A and B the same size, how far apart must they be for me to have this electrostatic force? Aha! So I plug in my new special 85% of the original electrostatic force. I plug in Coulomb's constant. I plug in the charge on A. I plug in the charge on B. And now I say, what is that distance? I know, it's not particularly pretty, but it is a 6-mark question. Alright, so I have to remanipulate this whole thing. So I end up dividing this top of the fraction by that, and then square rooting it to get R times 9. 7,4 exponent minus 9. I'm telling you now, if I had to mark this question, I would be particularly unhappy, because the level of positive marking that you have to be willing to do in this question is just insane. Right, the answer is 0,97624. I'm just writing down decimals, meters. Okay, so the distance between A and B is 0,976. You can carry on writing, you don't have to. You get the idea. They want to know if that is point P, how far from B do do I need to place P? How far from P do I need to place B? It is horrible. Horrible, horrible. This is one of those questions where, again, just like earlier up, I said to you guys that if you're not quite sure how to finish it, at least start it. Okay, R is always measured in meters. The question here is, if I calculate 15% of that first total and minus it from the original, will it give you the same answer? Answer from my side, yes it will. I just thought that this was quicker and less calculations. I am not very good at using my calculator, so I'm trying to use it as little as possible. Okay. Right, not a nice question, but it is the last question in this one. So I can understand that it is hard. I don't think it's quite fair, especially under pressure. But okay, electrostatics, the multiple choice. Names, surname, please, guys, just so that we have attendance. All right. So 1.7. Consider the electric field patterns below. And which of the respective charges, which of these lines, blocky GTs, is correct? So the first thing I did is I checked the direction of the field lines. And the direction of the field lines is going to tell you the sign of the charge. That arrow there means that the electric field is away from. So this means that this thing in the middle is a positive charge. That electric field line is coming towards the charged object, which means that negative there is what this is. Okay? And again here, the field lines are towards the charge, which means this is a negative charge. Okay, which means it cannot be A, because that has to be positive, negative, negative. It cannot be A. Positive, negative, negative. It could be B. Positive, negative, negative. It could be C. But there is a negative. It needs to be positive. So it cannot be D. So I have two possibilities. Either B or C. Now I look and I see, hang on a second, Q and R both have the same number of field lines around them, which means Q and R are the same size. But can you guys see that S has got like a gazillion? So gotta be C, okay? Because if S was the same size as Q and R, then it would have the same amount of lines. Okay, so it's got to be C. So the question is here. Okay, right, so that's electrostatics. Next one up is electric field. I just want to quickly go back and double check some of the questions in the chat. Right. So the question here is, in what order would you advise us to work through the question paper, mark allocation, all of these good things? It depends on you. Okay? I need time to warm up, so I always start with Doppler, which is like nice, you know, and then because I find the answering of electrodynamics relatively simple, I then do electrodynamics. That is not going to be true for everybody. Okay? That depends on you. Right. Next thing, if you are someone whose brain gets tired at the end of 3 hours, you cannot leave your worst questions to last. Okay? But if you are someone who generally doesn't finish a paper, right, then you leave your worst questions to last. You write them off. Okay? Don't get into the trap of answering a question, not being able to answer the next question, and then leaving the complete rest of the question out. Always go check, could I do the next one? Could I do the next one? Okay. So I cannot tell you which order to do them. What I can recommend to you is to do question 1 with its longer form question. Okay? Because the multiple choice questions can be harder. It's a lot easier to warm up your brain with the longer form question first and then go do the multiple choice question. Okay. So, electric circuits. I had a look at the electric circuits guideline. So, state Ohm's law is the one definition. It happens to be this definition. Then you need to be able to state the difference between an ohmic conductor and a non-ohmic conductor, and you need to be able to give an example of each. Ohmic conductor obeys Ohm's law. Non-ohmic conductor does not obey Ohm's law. Non-ohmic conductor, anything that gets hot. Light bulb, kettle, toaster, geyser, anything that gets hot. Ohmic conductors, the easiest is a nichrome resistor. Okay, so there's only really one ohmic conductor, a nichrome resistor. Alright, then power is a definition that's like all over the place, right? The rate at which work is done. And I am VI. So if any of you get the definition of power wrong, I'm going to be so sad. Alright, and then for electricity, the only other definition that they could ask you is for EMF, so the maximum energy per unit charge. Okay, yes. Yes. Okay, so, Ohm's law. Guys, they've asked Ohm's law every single year for probably the last 3 years. And every single time, I still see people start the definition with resistance is. If you check Ohm's law, the word resistance is nowhere in that definition. Okay? Ohm's law says potential difference directly proportional to current at constant temperature. Okay, V directly proportional to I at a constant temperature. It is that simple. Okay? Please, 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 pretty please, please. That's not a hard one. Okay. I think it's because you guys always think of Ohm's law when you are doing R is equal to V over I, and then your brains want to start the question or the definition with resistance is. Okay, so no, 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 no. Alright. Okay. Now, when I was going through the exam guideline, I reminded myself that there's this calculate the cost of electricity, and that I've never seen it asked in an NSC paper, and lo and behold, the Free State asked it in this paper. So I would be careful of not making sure you can do it for tomorrow. I don't know, niggly feeling. Okay, so they say I have a circuit. And in my circuit, I have a battery with a EMF of 10 volts, unknown internal resistance. Voltmeter V1 is connected over an open switch. V2 is connected over the battery. You've got a resistor, 6 and 3 in parallel, and 1 in series. You've got an ammeter, and as always, the resistance of the wires in the ammeter are negligible, meaning they don't exist. Meaning you don't have to worry about them in the calculation. Okay. Got it? Cool. So state Ohm's law. Then, for 1 mark, just 1 mark, what would be the reading on voltmeter 1? Voltmeter 1 measures the difference in energy between those 2 points. If the resistance of the wires are negligible, whether the switch is open or closed, voltmeter V1 will have a reading of 0 volts, because it's measuring that energy and giving you the difference, the minus sign. So whether that switch is open or closed, there is no change in energy between those 2 points. Okay. You see that open switch there? that means that the current won't flow. Can you guys see that? That voltmeter is horrible. It's like shingy. Okay? If there's no current flowing, V2 measures the EMF. If it's 1 mark like this, it's either measuring the EMF or giving you a 0 reading. Okay, so V2 measures the EMF. Okay, so when they say determine the, just be careful that you don't forget that it's 1 mark. Okay, right, cool beans. So now for the other calculations. Yeah, there we go. They say this switch is now closed. V1 is still going to have a reading of 0 volts. Okay? Got it? Cool. They say V2's reading drops by 2,5 volts. When they say that the reading over the battery loses, drops by when a switch is closed, that gives you lost volts. Okay, makes sense. Alright. So calculate the reading on V2. Again, it's only for 1 mark. I wrote out the whole shebang. Okay, you need to go 10 minus 2,5 is 7,5. Right? But you're going to get a mark for writing 7,5 volts. They aren't looking for a calculation because many of you should be able to do 10 minus 7,5 in your noggins. Brain. VPD stands for the terminal potential difference. It simply means the voltmeter reading over the battery when the current is flowing, where EMF is the voltmeter reading over the battery when there's no current flowing. Does that make sense? So you could have just used V2 or whatever. Okay. Alright. For 8.3.2, I'll move it back up in a sec. They want that ammeter reading. That ammeter reading measures the total current. In the previous question, they asked you for V2, which gives you the total potential difference. So if you have the total potential difference and you want the total current, you need to go and work out the total resistance. Okay, so the question here is, why will V1 still have a reading of 0 volts? Because V1 is still connected over a resistorless conductor. So the conductor does not use any energy for the charges to move from one point to another. So V1 just gives you the difference in energy between those 2 points. There is no energy used. Okay, so for this, I did my parallel thing. So it's 6 over 3. You can do your parallel calculation any way you want. Okay, you can do the flip right at the end. You can do the flip like I do it before I plug it into my calculator. You can use the product over something. There are many ways in which you can calculate the parallel resistance. Ultimately, the answer is that the 6 ohm and the 3 ohm have an effective resistance of 2. And then you add the 1. Now, when I worked this out, I wasn't sure where the marks would go. I do now know because I looked at the memo. Okay? But I always worry that they're not going to give me a formula mark somewhere, so I'm always overly careful and write down all the formulas. Yes. You can leave that like that and then flip it at the end. Because if you put 1 over 6 plus 1 over 3 in your calculator, you get 1 over 2. But remember, 1 over 2 is 1 over r parallel. I just always forget to do that step. I forget to flip. And so I do the flip before I put it into my calculator by doing the minus 1. Okay? So if that's not how you're used to doing it, don't change it now. Got it? Cool. Alright. Now, we're halfway through that sub-question, by the way, because they wanted us to calculate I. I know, right? Who decided that we needed to do a million things for one answer? I mean, seriously. Go. 7.5 is the total potential difference. It's the potential difference as measured over the battery. Why am I using total potential difference? Because that ammeter in the circuit does say, and that's why I was forced in the previous question to go work out the total resistance. Okay, some of you sitting here will be able to calculate that total resistance in one step. That's not me. Okay, and so now at this point, there we go, that's the start of the question. I go 7,5 divided by 3, and luckily I don't need a calculator for that. The answer is 2,5 ampere. Woohoo! All 6 marks. Thank you very much. Alright, which then brings us to the 8.3 question. If I can find that piece of paper. It's not that one. It's that one. Alright. Okay, so the question here on the chat is, shouldn't we account for internal resistance? That 7,5 there already accounts for internal resistance. That 7,5 already took internal resistance away. Okay. Now they ask us to calculate internal resistance. And guess what? You have options. You can either use that equation that you got given now on the formula page, or you can use a little weirdy one, or you can simply say the last volts is equal to the total current times the internal resistance. Okay. Keeping in mind that you don't get either of those two. Yes.
Can you just explain from the graph, or from the graph, the circle that gave us what is internal, bigger, big, or no, internal, small,
Yep.
what is
Okay. From a graph, the y-intercept is the EMF. Because you've got potential difference on the y-axis. The line where because it has a negative gradient. The line intersects the y-axis. That is my EMF. Okay. I'll have potential difference versus current. Okay. The gradient, the reason why there is a gradient is internal resistance. So that gradient of the line is equal to the internal resistance. M gradient equals internal resistance. Okay. The question here, wait. Last volts is not included, therefore until yes. Okay. The question here is, why are we dividing by 3? Okay. This I could write as 3 over 1. Why would I do that? So that I can cross multiply and get rid of fractions. So 1 times 7,5 is just 1. Right? I want I on its own. How do I get I on its own? It's 3 times I, so I divide both sides by 3. So I is equal to 7,5 divided by 3. Always remember, you can write as much math as you need to in order for you to be able to get to the answer. Okay. Right. So, because you guys get given this formula for that internal resistance, I thought when I did the problem, when I prepped, that I would use that formula so that you guys could at least see how that formula would work in this situation. Yes?
If you're using the first formula,
Yep.
E equals I is our EMF? 10.
Yes, was given right in the beginning. A EMF of 10. In the previous question, we worked out the current is 2,5. We also worked out that the external resistance, capital R, is 3. And we need to calculate the internal resistance. Right, so if I have to manipulate to get R on its own, the first thing I'm going to do is I'm going to take the 2,5 over. It's times 2,5. When I take it over, it becomes divide by. I press equals. So now I have 4 is equal to 3 plus little r. And so it's 3 plus. So then I go minus 3. So little r is equal to 1 ohm. Like I say, you could have used any of these to get there. Okay. Right. Only reason I use that one is because that's the one you get given in the formula page. So I wanted to just show you what that looks like. Okay. 8.5. How will the magnitude of the current passing through the 6 ohm resistor compare to that of the 3 ohm resistor? Guess what? Grade 9. It is literally a grade 9 concept. So, firstly, you need to remember that the 3 ohm and the 6 ohm are in parallel. The 3 ohm and the 6 ohm are in parallel. Right. So, the current divides. A bigger resistance will get a smaller current. Agreed? Yes.
No, how did you get to 1 ohm?
I went 10 divided by 2,4. That gives me 4.
I think you are going to take the 2,5.
I took it over.
Minus.
This side, it's 2,5 times all of that. So when I take it to the other side, it becomes divide by. Go. Alright, so bigger resistance, smaller current. And not only that, 6 is twice the size of 3. So if bigger resistance gets smaller current, and the two resistors are times 2 of each other, then the current will be half. Okay. They weren't looking for the word half, they were just looking for a smaller current will go through the bigger resistor. Okay. Make sense? Okie dokie. The multiple choice. They give me this weird circuit, and then they want to know what is the potential difference across that resistor. So what is the potential difference of V2 when I compare it to the rest of the blinking circuit? Okay, so I went back to basics. V, which is the potential difference of the battery, is equal to V1 plus V2. You see that? These two resistors are in series. Go. V is equal to IR. So the total potential difference is equal to the total current times the sum of the two resistors, and I can do the same for each of them. Go. Now it's about manipulating. They want to know V2. They want this value. So if they want this value on its own, I'm going to take that value over. So I'm going to have I R1 plus R2 minus I times R1 is equal to V2. What's my common factor? I. You pull I out. R1 plus R2 minus R1. What's R1 minus R1? That one and that one cancels out. Okay. And then I realized I was working in a bit of a circle. Can you see that? I kept on going bidi. Okay. And so I realized that times V here keeps on being over and over and over there. No? Okay? So I realized that here's V, and V is the potential difference for the total circuit. Can you see that? And so I realized that I can't just go V for R2 or V for R1, and I'm not minusing it. Okay. And that's how instinctively I knew that we had to go for D. Because the problem was that my normal math procedures here kept on working me into an absolute circle. So why did I choose D? Because V goes with R1 plus R2 and not with R1 minus R2 or just R1 or just R2. Okay. Okay. Right. So electrodynamics next and then mechanical energy. Now, the three of you sitting here, it is now 4:30. I will not force you to stay past 5. If we hit 5 and you want to stay, you may do so. Okay? If we hit 5 and you need to leave because of transport or whatever else, you may do so. Okay? Got it? Deal. This will be on YouTube, so just go find it. Okay, for the mechanics. I've got the links, but what I'll also do is quickly email them to you, the recording link. I'll send out a mass email quickly tonight. Do you want me to put it on the broadcast group? Cool, we'll do that. Okay. Right. This was an incredibly easy dynamics question. Like, so much fun. It is a horizontal rectangular coil. The coil has a current when there is an upward force applied. It's a weird way of saying. I turn the coil inside the magnetic field and it generates a current. This is a generator. Okay. Explain why there's a current induced. That is grade 11 concept. A current is induced when the coil experiences a change. That's the important word, change in magnetic flux. Okay, then determine the direction of the current. So, this is a generator. So we have to use right-hand rule. No one judge me for my right-hand rule abilities. You guys like weird hand. Okay, so here we go. F, B, I. Go. Now, again, in the question paper, do yourself a favor and turn your question paper. Don't try and get your hand all spaz. Okay, so my magnetic field, Gemma, I guess you have to say linkage. Must say change in magnetic flux, linkage. Okay, so magnetic field, north to south, and if you look at that F there, that is turning up. Yes.
When we use rotating coils,
Yep.
DC or AC?
Doesn't matter. Both DC and AC have rotating coils. It's not about the rotation, it's about the direction of current flow. Okay. Okay, so there. Can you guys see that the current? Sorry. There we go. So, north to south. That part there is coming up. So the current is flowing from A to B. Okay. So you have to use the right-hand rule for generators. Why? Because there's lots of R's in the word. Okay, so the answer here, it flows from A to B. Okay. A change is made to operate as a DC motor. Okay. Name the part of the component that makes it possible for the machine to operate as DC. DC, split ring. The word commutator is always in brackets. So split ring, DC. AC, slip ring. Alright. Name one change that can be made to produce a greater turning effect. Okay, so this question works whether you're working with generators or motors. Okay. There are three things that you can change. You can change the strength of the magnetic field, you can change how fast the coil turns, or you can change the EMF. Okay. When you are working with a generator, you cannot change the EMF because that's what you want out. So when you are working with a generator, your options are magnetic field, turn the coil faster. When you are working with a motor, you want the coil to turn faster. So you cannot say turn the coil faster. So it's magnetic field or stronger EMF. If in doubt, stronger magnetic field because it works for both generators and motors. I hope that makes sense. Okay. So they're asking for one change, any of those two. Yes.
Split ring is DC.
Split ring DC, slip ring AC, whether it's a generator or a motor. Okay, now, if you look at the exam guidelines, a lot of these things are state this, state that, state this, state that, all of these, okay? Again, no judgy, but most of these I have thrown through AI, double-checked them, verified them. You can throw these through AI and they will give you good, short, decent answers. As long as you make sure to tell them that you are doing grade 12 physical sciences in South Africa using the CAPS curriculum, okay? Because IEB and all the weird other ones are different. Then, the only other definitions that you could get here is the idea of RMS for voltage and RMS for current. Okay. RMS refers to AC. But it's really hard to do math with AC because the current is all over the place. That's why we are working, it's the AC that gives us the same amount of energy as an equivalent DC. Because we understand DC better. Okay? Right. And then solve problems. Right? So, I thought that that is where we were going with this question. I was convinced. Because that's how they always do it. 120 watt television and two 50 watt tungsten lights are connected to a 230 volt AC supply. When they make that statement and they don't tell you whether it's max or RMS, you always assume that that is the RMS value. Okay? Unless they're stating down here it is max or it is RMS, you assume it is the RMS value. It operates for 12 hours a day when switch S1 and S2 is closed. How long should switch S1 be open in a day while S2 is closed in order to save, oh my goodness, finance? Can you see how they flippin' hid the cost of electricity calculations? Can you see how they hid that? It's insane. Okay, now it's a huge 7-mark question. Personally, I think it's a little unfair just because it's not a calculation that is often done. But, okay. Now, I kind of looked at this and was like, well, okay? And I kind of wanted it to work backwards quite a lot, and I wasn't quite sure how to deal with that. But when I read through this, I saw that that TV operates 12 hours a day, and those two light bulbs in parallel operate 12 hours a day. And I realized that what I could do is work out how much that was. Does that make sense? I could work out 12 hours a day at that much wattage. I can go and work out how much energy is used. Yes.
There's one, the energy used over time.
P is equal to V over delta T.
Over time.
Yes. Do they want the time? How long should switch be open per day? Yes. Okay, so first thing I did is I said if that TV remember that is watts, and we are working in kilowatt. You see that kilowatt? So that's 1 dividing by 1,000 times the amount of hours that it runs. So the TV, when it runs for 12 hours a day, 0.12 times 12, uses 1,44 kilowatt hours per day. And the two light bulbs, each of them are 50 watts. Yes, I know they're in parallel, and I know you want to go and work out a weird thing there, but each of them is 50 watts. So the two light bulbs together is 100 times 12 hours a day. Is 1,2 kilowatt hours per day. Give me a sec. Yeah. But you can't work power in parallel. You can work resistance in parallel, you can work current in parallel, power isn't in parallel. Okay. Right. That means if we add those two together now, I am using 2,64 kilowatt hours per day. No? Times how many days in a week? 7. Which means if both switches are closed, I am using 18,48 kilowatt hours per week. But the question is, I want to save money. So what would be the next logical step? To calculate how much that would actually cost me. Why times 9? Because they say each. That's Taryn, they say both switches are closed. We want to know how long does one of the switches need to be open in order to save money. So firstly, we need to calculate how much it's going to cost if we have both switches closed 12 hours a day for 7 days. So that's what I'm starting with. I'm calculating baseline. If both switches are closed 12 hours a day for 7 days, then that setup costs me 66 Rand 32 cents a week. Okay? Agreed? Right. We want to save 36 Rand, right? We've got one or two options here. I would minus it here first. And then divide by the 9. Make sense? Then divide by the 9. So that I go from the money I'm spending, divide by the price so that I know how much energy I can spend. V2 divide by 9. So I can spend 14.48 kilowatt hours per week. Divide by 7. Why divide by 7? There we go. 2,0685 and change kilowatt hours per day. Okay. Can you see with both switches closed, I'm using 2,64 kilowatt hour per day, but in order to get that 36 Rand, I need to only spend 2,0685 kilowatt per day. Okay? So minus sum, 2,64 minus 2,0685 and change. 2,64 minus 2,0685. Go. I need to save 0.565715 kilowatt hours per day. Okay? They specifically said how long should switch S1 be open in a day for switch S2 to be closed. Okay? So this saving here can only come from S1. Can you see that? So what do you guys think we're going to do with this 0.54 and that there? I would take this value and divide it by, well, 120 watts, which becomes 0.12 kilowatt. Just give me a second to double check it. 1.5 divided by 1, no. 1.2. Yes. So this 0.5715 divided by the 0.12 kilowatts of the TV tells me hours per day. It's mean. I don't agree with it. Okay, so the question here was, can I go over it again? Yes. Okay, so I started by working out how many kilowatt hours does the TV use per day for a 12-hour day? How many kilowatt hours does the two light bulbs use for a 12-hour day? I added those together and I got that 2,64 kilowatt hours per day is used for all of this. There's 7 days in a week, and each of those kilowatt hours costs me 166 rand and 32 cents. The question was, they want to save 36 rand per week. That means that we can only spend 130,36 rand per week. So I worked that backwards. I went that divide by the rands per kilowatt hour means that I can only use 14,48 kilowatt hours per week. Divide by 7, I can only use 2,0685 and change kilowatt hours per day. With both switches open all day, I am using, 12 hours a day, I'm using 2,64 kilowatt hours. But I can't use that much. I minused, and this value here is how much per day I need to save. How much per day I need to save. So that save needs to come from the TV only. And that means that that TV needs to be switched off, switch open, for at least 4,67 hours per day in order to get that savings. Why do we minus blah 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 blah? Yes, you could do. Okay, so the question is, why aren't we minusing at a different spot? Guys, I have a feeling because of the dividing and multiplying thing here, I did it in an order that made sense to me. But I have a feeling that you could minus and or divide and or something at any point in this. Okay? As long as you go work out how much you need to save, how much kilowatt hours that represents, and then work using the TV, work it backwards to hours of that switch that it needs to be open per day. Okay, like I say, I have a strong suspicion that you could, once you have the total amount here, you could be minusing at very, very many places, I'm pretty sure. Is there going to be a financial question tomorrow? I don't know. Okay. Multiple choice. 1,9. Difference between AC and DC. DC generator uses brushes for commutation. AC generator uses slip rings. Both have brushes. B. DC generator produces unidirectional current. AC generator generates alternating current. I don't like the word unidirectional, but anyway. C operates at a constant frequency. AC varies its frequency. Not true. D. DC generator produces lower current than AC generator. Not true. Ladies and gentlemen, the correct answer here is B. Not unidirectional, unidirectional. Uni meaning one. Yeah, okay, fair enough. Good. Unidirectional, one directional. Oh! Really got me there. Guys, there's lots of people that are like arguing, can we work out how much we need to save per day and per week and all of that. Like I say, I am very, very sure that you have many options here. That is the road I saw happening. Okay. Okie dokie. Right. You guys want to stay? You want to go? No, I'm not going to take offense. I really am not. Okay. I'm not going to be upset. You really push really hard. I get it. Okay. Sorry, we're just having a quick class debate here. Okay. Right, guys, that is it for everything except mechanics. Exactly. Do the grade 11 stuff, do the easy stuff, ignore the rest. You'll be fine. Alright. Before we carry on, just for this last little baby bit of life, give me a second to get you. Maybe it's already there. Do you think? Wait. Sorry, guys. Let me see if I press Control and V, if it copies the correct thing into the correct place. Alright, let's see. Come on, mouse, you can do it. Yes. Okay, so everybody, if you are kind of running out of steam and stuff, take a break, pause it, because remember you can always come back to a live stream. I just posted in the chat, and you guys will probably get it later a little bit, the attendance register link again. For the PHA learners, what I am going to do is I will, before I go home, send out an email and on the WhatsApp broadcast group the link for the video after. Okay, because I don't know if the live link is different from the actual link. I don't know, I'm not that good. Okay, so travel safe, you guys. Alright, question 2, Newton's laws. 36 kilogram man, bottom of a 34 meter deep hole, position A, pulled vertically upwards from rest. Bar. At position A, inextensible rope attached to a tree. He reaches point B at the top. The tension in the rope is 780 newtons. Ignore the effects of air resistance. Then they start with state Newton's second law. And then what I did is I made sure I went and looked at every single possible definition, guys, that you could be asked. Normal force, frictional force, static friction, kinetic friction. Know that frictional force is. This is going to be important in a bit. State Newton's first law, state Newton's second law, state Newton's third law. Then state Newton's law of universal gravitation, describe weight, distinguish between mass and weight, and explain weightlessness. Newton has got so much basic content that they could ask. You need to be careful that you don't try and spot for tomorrow. Okay, so Newton's second law, when a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the magnitude of the force and inversely proportional to the mass of the object. It's not a new definition, guys. Okay. Question 2.2, draw a free body diagram. Just want to point out to you, also in your exam guidelines, they talk about free body diagrams and force diagrams, okay? Very important, I want to point out to you, you may never, when you do the thing for marks, include the components. Only ever the actual forces. Only use the correct labels. You must have an arrow on every line. I've seen you guys slipping up on this lately. And the mark allocation, 2 marks, is the number of forces you are drawing. Okay, so there's my dot for my free body diagram. Question 1 that I always ask myself, is this object that I am drawing a free body diagram of on planet Earth? I hope so. And so it experiences gravity. You are welcome to use W as well, as long as it is a lowercase w. Now I got stuck because I kind of went, well, the dude is standing at point A on the ground, so there's normal force, but there's also tension. And I realized that they are trying to ask this question in terms of when he is hanging on the rope at point A before he starts moving up. So it's 2 marks. There's only 2 forces, right? And if you look at the memo, they were looking for the tension in that string. Remember, 2 marks, 2 forces. 3 marks, 3 forces. Not in component form. Alright. Then they asked for 2.3, calculate the magnitude of a man's weight. And I started getting concerned because it cannot be that simple. Indeed it is. The man has a mass of 73 kilograms and gravity 9,8. And when you put that into your calculator, which I misplaced for a second, you get 715,4 newtons. 3 marks, easy marks, guys. I'm so hoping, wish and pray you get one of those tomorrow. Okay, then they said calculate the time taken to pull the man out from the hole from A to B, and I thought, yeah, nah. Oh my goodness, that was easy. Free body diagram was easy, definition was easy, and now they go this way. But I want to point out to you, pardon me, that at this point you already have 7 out of the, I can't remember how many marks this question counts. So the first 7 marks here are non-negotiable, and the last 3 marks I actually think are doable for all of you. So it's only the 5 marks here that are weird. Okay. So I thought to myself, these are typical calculations, FNet MA, and if I look at the free body diagram I've just drawn, then FNet equals FG plus tension. So what I did is I combined those 2 equations, and I said, okay, dude has a mass of 73 and gravity, so he's going to accelerate upwards hopefully. So gravity is down, so gravity is going to be negative in my life. And in the question they said the tension in the rope is 780 newtons. So I'm going to simplify for acceleration. And now I can hear the question going, man, why did you do that? Why did I do that? Because that is something I could do with the information that I got given. So I started, okay. So I got an acceleration of 0,88493 and change meters per second squared, and obviously it is up. Then I read the question again and I went to time taken. And I realized that they had told me that he is pulled up from rest. And the second that happened, I went, ooh, equation of motion. I read through the question again, and I saw that they gave me that distance of 34 meters. Now, I don't have the final velocity, but they are asking me, calculate the time it takes. And there you go. The second I saw this happening, I thought, yeah, nah. Here's a dude that likes to do interesting math, because he is going to force me to use interesting math in order to calculate that delta t. And then I saw, because of that 0, this thing falls away. And so luckily it's not a case of me having to do quadratic equations and all sorts of weird things, okay? All that ends up happening is I need to solve for this t squared here, which isn't that bad. So I'm going to go 34, and I'm going to divide 34 by a half times 0,8849. Just remember to put that in a bracket, otherwise you're going to get in trouble. And then that answer that I get in my calculator is t squared, and so I'm going to go square root of my answer. I end up with t is equal to 8,766 and change seconds. Remember, S, not S-E-C. Alright, so it ended up not being that bad. And I looked at the memo. If you could have done this, you would have gotten 2 marks. And then the other 3 marks is formula substitution and answer here on this side. Okay, 2.5 I thought was a very nice question. Will the tension in the rope be bigger when the man is at rest or when he is pulled upwards? Explain your answer. So when the man is at rest, the net force is equal to 0. So the tension will be equal to his gravity or his weight, which means the tension in that moment is only equal to 715,4 newtons. They tell me that when he's being pulled upwards, there's a tension of 718 newtons. And so if he is being pulled upwards, the tension in the string needs to be bigger than his gravitational weight. Okay, that's a relatively simple question. I thought it was quite a nice question. Alright, so that is the longer question for Newton. Now we go to the multiple choice. Okay, so the Newton multiple choice was 1.1, 1.2, and 1.3. Right, here we go. Book lies on a table. It does not move. F net equals 0. Let's go. The force exerted by the table on the book is equal to the force exerted by the earth on the book. Not untrue. Maybe. I don't know. Let's see. The force exerted by the table on the book is greater than the force exerted by the earth on the book. Ladies and gentlemen, if that was true, the book would be flying up. 3 marks for what exactly? So the 3 marks went for tension is greater when he's being pulled upwards. When he is at rest, tension equals gravity. When he is being pulled upwards, tension is bigger than gravity. Okay, those were where the 3 marks are. Again, I thought it was an unfair 3 marks. Okay. So, firstly, that's wrong, because if the force of the table was greater than gravity, then the book would go flying off the table. Anyway, there are no forces acting on it. Never, ever, 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 ever true. Ever, ever. Okay. So we're stuck between C and A. Now, the forces acting on the book are in equilibrium. If you compare A and C, they are similar, but C is definitely by far the more correct scientific explanation. Okay? Because remember, there are other forces acting there. So I would definitely go for C. Alright. 1.2, and this is where it's important that you know the things that affect friction. A maximum force of 8 newtons is exerted on a 6 kilogram block. The block is at rest and just about to move. Okay, that just about to move tells me about the tendency of the motion. It's on a rough surface. We're talking about friction. Which one of the following will increase frictional force? Ladies and gentlemen, frictional force, F is equal to normal times mu. So frictional force will only increase when the normal force increases or when the coefficient increases. The coefficient is only dependent on the contact of the 2 surfaces, the type of surfaces in contact with each other. So, friction is independent of any applied forces, so it cannot be A, it cannot be B. If I rotate the box, you need to remember that friction is independent of contact area. It's only dependent on contact type. So 1.2 is also C. And then I always panic because I have 2 answers that are the same. Okay. Acceleration due to gravity on the moon is G. There. Moon, radius of the moon. So, if I have a planet that is 3 times the mass of the moon, but 1/3 the radius of the moon, what will its new G be? So I always then say, okay, G is that, the new acceleration is that, and I pull the numbers out. Here's G, and then into my calculator I say 3 divided by 1/3 squared, which is 27. So the answer is B. Okay. Right, then the things that are in the exam guideline that you guys need to keep an eye out for, just go read through these so that you know exactly what you could be asked to do and the examples they could give you. Alright guys, we are so almost there. I know you're getting tired, we're okay. Right, question 3, VPM. Ball is dropped vertically downwards, top of a high building. Which one of, 1 second later ball B is dropped. So now keep in mind that the time A is in the air is 1 second longer than B. So if you're working time of A, you're going T plus 1. If you're working time of B referring to A, then it's T minus. Anyway, okay, B is thrown downwards, speed of 30 meters per second. They ask here what is meant by projectile. This is one you guys struggle with. Object which has been given an initial velocity and then moves under the influence of the gravitational force only. Okay, and then free fall is the other definition that you could get there. Alright, so for the calculations, they say use equations of motion only. I think that's cheeky, but anyway, here are my equations of motion. Those of you who don't normally have class with me, I always choose up as positive, down as negative. Anyway, so for 3.2.1, calculate the time it takes for ball A to travel 12,5 meters above the ground. It starts being 25 meters above the ground, so that difference there is how far it must travel to be 12,5 meters above the ground. They say A is dropped. They don't give me a final velocity. Acceleration is always 9,8 meters per second squared down. And this drop is also down. So it is also negative. So I want delta T. And again, I looked at it and I went, really? Seriously? What are we doing? But then I realized that V is 0. VI is 0, pardon me. And so again, that one part of that equation falls away. Okay, so 25 minus 12,5. I must be very tired because I didn't realize that that would also be 12,5. But anyway, so there's 12,5. Why minus? Because it's down. Then initial velocity time plus a half times gravitational acceleration T squared. Right? So that falls away. I'm going to say minus 12,5 and divide that by 0,5 times minus 9,8. That gives me T squared, and so in order to get just T, I put a square root over it, and I get 1,597. Now you could leave it as 1,597. You could round it to 1,60. That is completely up to you. Alright, so it's scary on the face, but when you start calculating it, it's not actually quite that bad. Alright, then 3.2, the time it takes ball B to pass ball A for 6 marks. So I wrote down all of these blinking values that I have, and this is where it is important to realize that if you're going to work with B as having time equals T, then A is traveling for 1 second longer, and so A has to be T plus 1. Your other option is to say A travels for T seconds, and then B travels for T minus 1 second. Okay, I wrote down all of the variables. I used Y for the height. You could use any height value. Okay, ultimately we want to know how long does ball B travel. That's why I made BT and not AT, when they are at the same height. Okay, and as you can notice, yay, our favorite flippin' equation making its way back the whole time today. Oh well, we can do this. We might not want to, but here we go. Okay, so for ball A, I have the distance times, oh yay, look, it makes that 1t at least disappear, plus a half minus 9,8 t squared. Then for ball B, I also want to know y, how far it's travelled, but here we are not so lucky. Guys, my bad. You guys are probably all shouting at me across the screen. Ma'am, what about the plus 1? Caught it. So that's plus 1 and there's the square. Okay, so now the initial velocity of B they they say it is thrown downwards at 30 meters per second. T squared. Okay, and now the argument here is that y and that y is the same, and so if they are the same, you can make them equal to each other. Obviously that becomes 0, so I'm going to drop that at this point in time, and I'm going to start simplifying as far as possible. I know it's not always possible, but I'm going to start trying. Okay, and so I've got t plus 1 squared. You could have also multiplied this out, but that might be one step too many in one go for my brain today, but we're going to try. Minus 4,9 t squared. Okay, so now the biggest thing I need to do here is multiply this thing out, simplify, and then get to t. Right. So, I am able to identify that that thing is t squared plus 2t plus 1 equals, there's not much I can do this side, so I'm just going to leave it, minus 30t minus 4,9t squared. Okay, multiply this thing out and I get minus 4,9t squared. That times 2 gives me minus 9,8t minus 4,9. Now I'm going to start throwing things over so that I can get one side equal to 0 at least. And luckily, look at that. Oh my goodness, t squared, they cancel out. So I can simplify, and I get 30 minus 9,8 gives me 20,2t. And now I'm kind of feeling guilty because, oh wait, no, this comes from there. So if I take that over, it's equal to 4,9. So t is equal to 4,9, no, not minus, 4,9 divided by 20,2. It is the smallest little baby number in the whole wide planet. Okay, 0,2425, so I'm just going to go 24 seconds. Remember, S, not S-E-C. The thing I can't say out loud. Okay, so the question is the time it takes ball A to pass ball B. Ball A is in the air for 0,24 seconds when it passes ball B. Okay, that's why I use T for ball B and not for ball A. Alright, I hope that makes sense. Ugly, not the worst, but you know, not beautiful. Okay, now they're asking an incredibly simple question, and this is where I always remind you, please, 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 if you struggle with one question, don't not look at the next question. 3.2.3, calculate the speed of ball B when it reaches the ground. Oh my goodness, ladies and gentlemen, initial speed, you want the final speed, you have the distance, you have the acceleration. Like, I don't quite know why they swapped those two questions around. They did, but if you now struggled with 3.2.2 and you didn't bother to do 3.2.3, then you threw away 3 marks. Okay, so you need an equation without time in it. There it is. So we're just going to substitute in from the values we get given. Some of you guys will probably mathematically be a little bit stronger than I am. Luckily, that's okay with me. 2 times 9,8 times 2,5. Okay, so on this side, before I square root it, I get 1,390. And if I square root that, I get 37,282. So I'm just going to leave it like that, meters per second. They say speed, scalar. Okay, so now I get the same query I thought I was going to get about B. So, if we read 3.2, the time it takes ball B to pass ball A, not the time A is traveling when B goes past it. The time B is in the air when it goes past A. So, this time here is the time that ball B is in the air when it goes past ball A. So, if you had worked with the time for A, you would have gotten that your time is equal to 1,24 seconds. Okay, so then you would have to minus that 1 second to get the time that ball B was in the air before it went past ball A. Okay, it's not a stupid question, it's actually quite a good question. It did take my brain a while to wrap around how they decided to mark that. Okay, so don't be too worried about it. Okay. Right. So for 3.2.3, a very, very simple question. I don't want to say it's easy, but you know, it's not as difficult as 3.2.2. So yeah. Right. Then graph. Remember, you can be asked to sketch graphs. You could be asked to do calculations with graphs. Okay? Make sure you know. They say on the same set of axes, draw a position versus time graph for A and B while they are in free fall. So when they get thrown until when they reach the ground. Okay, so there's my two axes. I am taking the ground as 0. So ball A is dropped. Okay? Ball A is dropped. So it doesn't go up. And it's the most natural thing for us to want to go like that. But ball A is dropped. Okay. Then 1 second later, ball B is thrown downwards. 1 second later. And at 1,24 seconds, as we calculated earlier, ball A and ball B is on the same spot. Make sense? So, they are both sent from the same height. Now, indicate the initial height of the building, the times at which each ball is thrown, so 0 and 1 second, and the time at which ball A passes ball B. Maybe I should just indicate it more clearly. So just be careful. That is the line for A, and that is the line for B. I know that in the memo they also indicate the times it takes for ball A and ball B to reach the ground. That is not asked. The mark goes for, pardon me guys, the mark goes for correct heights, correct times for A and B. So these two times, that, both balls end on the ground, and both things are labeled. Okay, I think it's silly. I wouldn't have given it that many marks, but hey, that's just me. Okay, so height must be the same. That time there, the time they go past each other, and make sure that you label each of your graphs. Okay. For this question paper, there was no vertical projectile motion multiple choice. I looked 3 times and there is none. Okay. 2 questions to go, guys. We're almost there. Yay, momentum. Okay. Car, truck. Car drives at 25 meters per second in east, and so you can see I'm deciding east is positive. The truck is moving at 15 meters per second, also east. And then the car collides with the truck. Sorry guys, I'm just quickly letting remotes know that I'm still in the school, because I really don't want to get locked in and then make things go boom. Okay, anyway, so car with a mass of 1,200 kilograms moves at a speed of 25 meters per second east, crashes into the back of a truck. I'm choosing car as 1 and truck as 2. The truck has a mass of 6 tons, 600 kilograms. It moves in the same direction, so also positive, 15 meters per second. Velocity of the car after the collision is 16 meters per second east. So can you guys see everything is east? Everything is east, so we're just going to go east is positive. Happy days. Ignore friction and rotational effects. That means we are working with an isolated system. Okay, write down the principle of conservation of linear momentum. So just be careful. Momentum. You could be asked to define momentum or describe linear momentum. You can be asked to state Newton's second law in terms of momentum. You could be asked to define impulse. You could be asked to explain what is meant by a system, an isolated system or an open system. And then the one you guys always seem to memorize is conservation of linear momentum. Okay? But you could also be asked to explain what is meant by an elastic or an inelastic collision. Right. So they want the total linear momentum of an isolated system remains constant. Okay, that is what they always want for there. Now, typical question, thank goodness. Calculate the velocity of the truck. Please note, calculate the velocity of the truck after the collision, not the speed. You don't write the direction, you are not going to get marks. Okay. So I write down all my variables. Okay, why? Because then I don't make silly mistakes. So the formula given on the information page, sum of the momentum before the collision or explosion is equal to the sum of the momentum after. You have to expand initial momentum and final momentum. Alright, let's substitute. 1,200 kilogram moving at a speed of 25 meters per second collides with a truck of 6 tons, 6,000 kilograms moving at a speed of 15 meters per second. And afterwards they tell me that the car has a velocity of 16 meters per second, and they want to know what is the velocity of the truck. So I calculate that side first. 1,200 times 25 plus 6,000 times 15 gives me a lot. 120,000. Right. Then I'm going to take this over, so I'm going to say minus 1,200 times 16. That means I'm left with 100,800, and then I'm going to divide it by the 6,000. I am left with 16,8 meters per second east. Why? Because it's calculate velocity, not calculate the magnitude of the velocity, not calculate the speed, calculate the velocity. I am begging you, please don't do that tomorrow. Please don't ignore words that mean it's a vector and then don't write a direction. Okay, next question was fascinating. They say calculate the mechanical energy lost during the collision. And I went, And then I realized that mechanical energy is potential energy plus kinetic energy, right? So change of mechanical energy is normally the change of potential energy plus the change in kinetic energy. And then I realized that the potential energy in this system is going to stay constant because they are traveling on a flat horizontal road, which means the change in mechanical energy is equal to the change in kinetic energy. And then I realized what the question was about, because for elastic and inelastic collisions, we go and see, is there a change in total kinetic energy? So, initial kinetic energy, there is, of course, positive marking there where it is required. For this first step, they give you all, whoopsie, sorry, I missed 0. They give you all the values. So it is, there's no positive marking in that initial kinetic energy. Plus 0.5 times 6,000 times 15 squared. Huge, huge. Let me just go make sure that I write the right spots and the right things. 1,050,000 joules. Right. Whoop. Then we do the same for the final kinetic energy. And again, remember, here we got given the speed of the car after the collision, but we calculated the speed or the velocity of the truck after the collision, and so that will obviously be positive marking if needed. Plus 0.5 times 6,000 times 16,8 squared. Okay, again, not a small number, 1,320,000 joules. So it's final minus initial. Final minus initial. Energy, ladies and gentlemen, is a scalar. You cannot change the negative. Alright? You cannot change that negative. What you could say is the kinetic energy or the mechanical energy of the system decreased by 49,680 joules. Right? You can say that. Okay, and then they ask an explain question. They say, explain why mechanical energy is lost. And my initial gut feeling was, wait, what? And then I realized, but hang on a second, the change in mechanical energy is the change in kinetic energy. And when is the kinetic energy before the collision not equal to the kinetic energy after the collision? The collision, I don't know how many S's, or, yeah, okay, one is. The collision is inelastic. Right, now that would get you 1 mark, but it's a 2-mark question. So, I ask myself, what happens? Where does it go? Right, think about it. It is transformed into, what do you hear when there's a collision? Sound. Cars get reshaped. heat. There are many possibilities of where that energy goes. Okay. It was, I think, a little bit of a mean question. I wouldn't have asked it the way they did there, but yeah, it's interesting, but I still don't think it's particularly a nice way of asking the question. Okay, that was it for the long question. There was only one multiple choice question for momentum. It says a body falls freely in the absence of air resistance, so closed system. Which physical quantity of the body is equal to the rate of change of momentum? Ladies and gentlemen, rate of change of momentum is Newton's second law in terms of momentum. The net force is equal to the rate of change of momentum. When an object is in free fall, the only force acting on that object is the force of gravity. Okay? So, it can only be the object's weight. Don't go and fall for that mass option there. Do not go forward for that mass option there. Ladies and gentlemen, we have made it this far. One more question to go. Work, energy, power, whip. Okay? And somehow, I didn't plan it this way. I'm sorry. Somehow, we ended up doing the graph last. Okay. Cool. Here we go. 8 kg steel ball, initially at rest. Oh, highlighter. Initially at rest. It's pulled by an electric motor with a constant applied force, there we go, applied force of 45 newtons. Ball moves at a constant speed, so we've got x, y, and y, z, okay? And the graph below shows the kinetic energy in the distance. So keep in mind that here is x, and then it moves 4 meters to point y, and then it moves another 4 meters to point z. Okay, so that's what they're trying to tell you with this graph. Don't panic about it too much. Okay, first one, define conservative force. Again, for work, energy, power, you could be asked to define the work done by an object by a define the work done on an object by a constant force. You could be asked to state work energy theorem. You could be asked to define a conservative force and a non-conservative force. That's where we're going with this one. You could be asked to state principle of conservation of mechanical energy and good old faith. I really do hope you guys get this one, because then you can giggle, because then you write me down, VI. Right? Definition of power. Right, so non-conservative force, very important, it is a force. The work done in moving an object between 2 points depends on the path taken. Non-conservative depends on the path taken. Conservative does not depend on the path taken. The only conservative force you have in grade 12 is gravity. All the others are non-conservatives. Okay. I got a note here. We can look at it. We can look at those two questions, and I'll tell you kind of how I would have dealt with them, Kiara. We don't have to go into detail with it. Let's see, we did Doppler effect right in the beginning, so you want to scroll back to right in the beginning of the live stream and go through Doppler. It's a nice question. It's a nice, easy question. Okay. Now you guys all panic because we need to use the graph. No, man. 5.2, use a suitable formula and show the physical quantities represented by the slope of the graph. Okay, ignore that for just a second. Can you see it's a straight line? Can you see it's a straight line? Straight line graphs. Y is equal to mx. Why not mx plus c? Because it goes through 0, 0. What is on the y-axis? Ek. What is on the x-axis? Distance. Okay, so the gradient is whatever is not there. Cool. Now, you go to your formula page and you find something that has got an EK in WEP, work, energy, power, and you will see that net work done is equal to the change in kinetic energy. And kinetic energy is on the y-axis. And now we need to manipulate this part so that we've got something that's on the x-axis. And oh my goodness, work done, net force times distance times cos theta. And so if that is what is on my x-axis and that is what is on my y-axis, if we ignore the weird trig relationship for now, then the gradient, ladies and gentlemen, is equal to the net force. Booyah! If you can get something like that in this question, the rest of the question is easy. Okay? Learn how to manipulate a formula, force it into a graph. Okay. Now, they say, calculate the net force experienced by the steel ball as it moves from x to y. X to y. Net force. Net force is equal to gradient. Okay. You could have gone that route. Problem is that you don't have frictional force. You've got all the others. But you're going to use this one later on. Anyway, so you're going to use the gradient, okay, for y, z. So z, I followed across 160, and I had to do some magic math here, and I got that value as 24. So there's 5 between 40, long story. Okay, cool. So I worked out the gradient, and I got that the net force is equal to 34 newtons. Okay. Now they say, and this is the question that apparently was dropped, but I still think it's fair, relatively easy, the magnitude of the frictional force experienced by the block as it moves from y to z. So, you just worked out the net force that that block experiences. They give you the applied force of 45 newtons. You want to calculate the friction. Wait, that's not clever. The friction is going in the opposite direction. So why on earth not just make it negative? Alright, then gravity down. Negative. It is an 8 kg steel ball. It is the parallel component of gravity, and so I'm supposed to be using sine. And they tell me it is an angle of 25 degrees Celsius. Right? So, let's see what happens when we plug all these values into a calculator. Because maybe here is where the problem is, and someone didn't do a good calculation. Hang on. 34 plus, okay, no, we're going to take that up. Minus 8 times 9,8 times sine 25 bracket. And take that over, minus 34. Aha! Okay, guys. You see that minus there? I get minus like that. Which means, just bear with me, that friction is in direction of motion. And that is a physical impossibility. And because this is wrong, everything else falls flat. Okay, so that is why they pulled that question, similar to what you guys ended up getting. Okay, so I'm not going to do 5.3.3, which I carried on doing there. Okay, anyway, let's have a look at 5.4. They want to know which of the two has the greatest frictional force. Okay, so keep in mind, flat gradient, steep gradient. The gradient is equal to F net. So, xy has a smaller gradient than yz, which means smaller F net, bigger F net. If it has a smaller F net, can you guys see that it's going to have a bigger frictional force? That is important. XY has a smaller F net, therefore it has a bigger frictional force. Oh, I said degrees Celsius. It is possible. It is possible. It has been a long day. I've taught LO today, and I've taught all about stars and greenhouse gases and like all sorts. I don't have a brain left at this point, but it's fine. We're almost done with the paper. Okay, so XY has the smaller F net, therefore it has the bigger frictional force. And why can I say that? Because XY has the smaller gradient. And thank you for helping each other out in the chat when there is a question that I am not able to answer. I really do appreciate it. Alright guys, last multiple choice. Got this. And actually, this is a math application. I have a feeling tomorrow is going to be similar. So you're going to write math while you're supposed to write physics. Because while you wrote math, you wrote English comprehension. No, that's how I hear all of you say it. Okay, they give you a graph of EK versus V. And I want to remind you that EK is equal to half mv squared. So if you look at any of these graphs, ladies and gentlemen, there's only one graph that looks sort of, even remotely, like a squared function, and that is a... Okay. Alright, ladies and gentlemen, that is the end of my story. I have only one piece of advice for you. No, I have many. You have the right to write that exam. You have spent several years in high school in order to write that exam. Go write that exam, sit tall, breathe deep, and you do the question paper in the order you need to do the question paper in. Today, I started with Doppler because I needed to have some fun after a really tough day. You guys then needed to go to electric circuits. I had planned to leave it a little bit later because the mechanics tire me out, which is why I'm really struggling at this point in time. Okay? Thank you so much for sticking with me. If you are from a different school, please share. We are going to do one again tomorrow. My physical sciences students at PHA, I will send you a WhatsApp as well. If you need it to be earlier, we can move it earlier. Okay? I'm not forcing this late session, but the rest of the school finishes at the rest of the school finishes at 1 o'clock. And so the earliest I can help you is 1:30, right? So if you need it earlier, let me know. Those of you who need a space to come and sit, my class 7-7 is available. Those of you who are at PHA, please, will you complete the attendance register using the Google form that I put in the chat several times? Let me do it again. The other kiddos, you won't be able to access that Google form because it is only set for PHA emails. Okay, guys, so please, you guys have my email. You can put it in the chat as well. You can have a conversation, but I need to know tomorrow morning as you guys start writing so that people that joined us who are not at PHA, I can go and change the description so that they know what time we're starting. Okay, but like I say, I'm here for you guys. I'm here to serve you. We made it a little bit later so that I could make sure that you guys all got home. But I also don't want to force you to be on a stream forever and a day. So I need the PHA guys to go and have a vote. And you can send a rep to me. I'm going to be in 77 all day. Many of you do have my cell phone number. You're welcome to send me a WhatsApp. Let me know what time works best. Anytime after 1:30, I can help you. we cannot start later than 3, otherwise I'm going to be here forever and a day. Ladies and gentlemen, good luck for tomorrow. Enjoy. The question, will tomorrow's test or exam be on this level? I have a suspicion it will. They have been upping levels this year by a lot. That does not mean that they won't adjust marks, but I cannot speak to that. I didn't choose this paper because I thought it would be similar to tomorrow's. I choose it because Free State sets good papers. They set papers that are mostly mistake-free. So yeah, if you are worried, go work through last year's matric paper just before you go in, or my stronger recommendation is that you guys go through your definitions. If you get your definitions wrong, I'm going to be so upset. Anyway, guys, good luck. Know that my thoughts and prayers and everything is with you, and enjoy it. I know it's been a tough exam, but go enjoy it. Alright, I'm going to stop the stream, but you can still keep on chatting, and yes, please, PHA learners, let me know what time best suits you, and then we will adjust. I will send the link to this recording on the broadcast group as well as on the email for anyone who couldn't join us today.